Hi guys, so today we're gonna talk about the 5 different types of images that you can use in ImageJ. And so here I already opened ImageJ already, and there are some pictures that I might use for during this tutorial. So if you go to image and type, you can see there are 5 different types of images that ImageJ supports. So 8-bit, 16-bit, 32-bit, 8-bit color, and RGB color. So I'm going to talk about the first two first. So 8-bit and 16-bit are kind of similar because you can consider them as black and white images. And for 8-bit image, it means the grayscale of the image has 2 to the power of 8, which is 256 steps, and between black and white. In other words, the grayness between black and white is divided into 256 steps. And for 16-bit, it means there are 2 to the power of 16, which is 65,536 steps between black and white. So you can say that for 16-bit, you can assign more gray level, much more precise for each pixel than the 8-bit. Or in other words, you can say the grayness resolution is higher. So to demonstrate this, I have an example to show. So we go to File, New, Image. Here, what I'm trying to do is trying to create a new image, 8-bit image here with 10 pixels width and 15 pixel in height, and say OK. So here's our image. It's all black back, and say I want to draw on this picture. Click this pencil tool and just randomly draw. I'm gonna just draw a diagonal line. You see the line that I draw is gray, which is why they call it grayscale. Now if we go back to File, Save As, Text Image, and say Save as Desktop, Save, yes. Okay, so let's open that file that we just saved. Okay, here it is. You see, okay. So you see a whole bunch of zeros in 134. They basically represent the color. So 0 representing black, and 134 is just a random number, that random green number that's between black and white. And for white is the largest number, and in 8-bit the largest number is 255. So if I change some of the 134 to 255, and save, let's close this and also close this one. Now what should happen is that for the ones that I've changed to 255, the pixel should be white in color. So let's go import text image, find our file, here it is, and yes. So you see those are still 134 and they are green, and for those that I've changed it's 255 in the text file, and it's white. So that proves our point. Okay, so that's for 8-bit and 16-bit. Now for 32-bit, it's called a floating point image. A floating point basically means that it uses real number rather than integers. So for 8-bit and 16-bit, we use integers, say 0, 1, 2, 3, 4, 5, 6. But 32-bit, it uses real number like 2.35 or 3.2461, etc. There's some problem with real numbers for an ImageJ, or for some functions, not all of them. So sometimes you have to convert from 32-bit to a 16-bit or 8-bit. I think that's all you should know about 32-bit for now. Yeah. And for the last two, the 8-bit color and RGB color. Okay, I'm gonna talk about this one first, RGB color. So in RGB color, there are three different channels or layers. The first one being red, second one green, third one blue, and each one of those layers is an 8-bit file, image file. Okay, to prove this point, let me import the image. Just simply drag it onto the ImageJ, and let's go image. No, what I'm trying to do here is to prove that there are three different layers in RGB image. So what you do here is go to image and color, and just split channels. See, it split it into three channels: red, green, and blue, and each of them is an 8-bit image. So sometimes you can some people refer RGB color image as a 24-bit image because it's 8 plus 8 plus 8 is 24-bit image. Okay, now you have a basic understanding of RGB color type image. So basically it's a 24-bit color image with 8-bit assigned to red, 8-bit assigned to green, and 8-bit assigned to blue. So now it's easier to understand 8-bit color image. In 8-bit color, there are 3-bit assigned to red, 3-bit assigned to green, and 2-bit assigned to blue, which makes a total of 256 colors for 8-bit. So if we say convert this RGB image to 8-bit color and compare with the original image, now you see the difference. This RGB color looks much better, especially in this area, the background. And you can also tell from the size of the image. You convert it from 24 to 8, the size have also reduced. So that concludes our tutorial on image types. Please subscribe. If you have any question, just leave me a comment. And thank you for watching.